All right, here we're going to be working through scientific notation practice. So we're going to take regular looking numbers and turn them into scientific notation. And then we're going to take scientific notation numbers and turn them into common notation. So remember, scientific notation consists of two parts. It has a number where there's only one non-zero integer in front of the decimal, and then a times 10 to the, and then an exponent. Remember that if it is a positive exponent, then that means the number is bigger than 1. Ooh, I guess I'm off the screen. Here we go. If it's positive, it's bigger than 1. And if it's negative, then that is smaller than 1. Okay, so this is what we're going to be looking at in terms of making sure we have in our scientific notation practice. So the first one, number 1, the first thing you want to do is figure out where the decimal is. So we've got one right here. The next thing we're going to do is figure out where are we going to stop. Well, we want one non-zero number in front of the decimal. So that's going to be our number 4. It's just whichever number is first. So now I'm going to move the decimal to the right until there's only one number in front. So 1, 2, 3, 4, 5. I moved it 5 places to have my decimal where there's only one number in front. So if I rewrite this, 89, 4.89, that's my number. And then my times 10 to the, representing how many times I moved the decimal. Well, I moved it 1, 2, 3, 4, 5 times. So that is a -5 because it is smaller than 1. And I moved it 5 times. So this 4.89 times 10 to the -5th is this number expressed in scientific notation. Okay, now let's take a look at number 2. First things, just figure out where the decimal is. So it's going to be at the very, very end because it's not written in our number. Now this is a really big number, so we're going to end up moving the decimal to the left until we have one non-zero integer in front of the decimal. So that would be between the 1 and the 9 right here. So here we go. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 times. So there's two parts, the number 1.92. Well, that's a funny looking 2, but 1.92 times 10 to the, remember that is representing how many times we move the decimal. And then since I moved it 8 times, my exponent is 8, and it's positive because this number is much bigger than 1. So it is a positive exponent. Let's look at number 3. So first thing is figure out where the decimal is. It's going to be after the 0 because it's not written in our number. We want one non-zero integer in front of the decimal. So that means we're going to move it until it's between the 5 and the 7. So 1, 2, 3 times. So I rewrite my number, 5.73 times 10 to the, and then I moved it 3 times. It's a positive 3 because this number is larger than 1. Okay, let's look at number 4. I've got my decimal. It's in my number already, and I'm going to move it to the right until there's one non-zero integer in front of the decimal. So that's going to be between the 1 and the 7. So 1, 2. So I rewrite my number, well, 1.76 times 10 to the -2nd. It's negative because this number is smaller than 1, and it's 2 for the exponent because I moved it 2 places. So if you look at all 4 of these examples, there's only one number in front of the decimal. It has to be between 1 and 9, okay? And then we have our number, and then our times 10 to the, representing how many places we move the decimal, and our exponents. Remember, it's positive if it's bigger than 1, and it's negative if it's smaller than 1, okay? If we look at our next set of examples here, we're going to convert these into common notation, meaning we have it in scientific notation and we're just going to take it out and make it look like a regular looking number, okay? So I'm going to rewrite this, 9.76. This times 10 to the is telling me I'm moving the decimal 2 places. Now, this exponent is positive. So this means that this number is a big number. It's bigger than 1. So I'm going to think about which way do I move this decimal to make sure that this number is bigger than 1. If I move it to the right, then I have a larger number than 1. And I'm going to move it 2 times. So 1, 2. So if I rewrite this number, I'd have 976. So 9.76 times 10 to the second is the same number as 976. This is expressed in scientific notation, and this is expressed in common notation. Okay, let's look at the next one. 7.33 times 10 to the negative fifth. So I'm going to rewrite 7.33. The negative tells me that this is going to be smaller than 1. So I'm going to move the decimal to the left to make this number smaller than 1. And since it's 5, I'm going to move it 5 times. So here we go. 1, 2, 3, 4, 5. Over here, all these empty spots I'm going to fill with zeros. So 0 point, I always do a 0 and then point for a decimal. 1, 2, 3, 4 zeros, seen here. 7, 3, 3. So 7.33 times 10 to the negative fifth is 0.0000733. Okay, let's look at the next one. 1.35 times 10 to the negative first. 1.35. I rewrote it so I can move the decimal around. The negative tells me that this number is smaller than 1, so I'm going to move the decimal to the left in order to make it smaller than 1, and I'm just going to move it 1 time. So 1 spot to the left. So this number expressed in common notation is 0.135. Okay. The last one, 3.00 times 10 to the 8th. Okay, so we're going to do the same thing. Here's my decimal. I'm moving it 8 times, and I'm going to move it 8 times to the right to make this number much bigger than 1. So 1, 2, 3, 4, 5, 6, 7, 8. All of these empty spots is for a 0. Now remember that the times 8 part doesn't mean you tack on 8 zeros. It means you move it 8 decimal places. So keep that in mind when you're doing the practice. So our answer would be 3, 0, 0, 0, 0, 0, 0, 0, 0. Okay? And that would end up being the 3.00 times 10 to the 8th. So that's how we convert between common and scientific notation.